Hello everyone, I hope you're all doing well. In this concept talk, we're going to be looking at moment of a force about a point, and we will be employing what is called as a scalar approach. Okay, first of all, we will define moment of a force. So moment of a force about a point. Okay, moment of a force about a point is defined as the tendency of the force to cause the body to rotate about that point. Okay, so this is the tendency of the force to cause the body to rotate about that point. Okay, so that's the first thing. Moment is a vector. Okay, so moment is a vector. And there are, I guess, a couple of good reasons for this. The first thing is that the magnitude of the moment depends upon the magnitude of the force, how large or how small the force is. Okay, so the magnitude of the moment depends on how large or how small the applied force is. Okay, and then the magnitude of the moment also depends upon where the force is acting on the body. Okay, so magnitude of the moment depends on where the force is acting on the body. And lastly, the direction of the moment depends upon the direction of the force that is applied on the body. Okay, the direction of the moment depends on the direction of the applied force. Alright, so the key statement here is that moment is a vector. And it's any tendency of a body to cause, a tendency of a force to cause a body to rotate about a particular point, or sometimes about an axis. When the rotation is about an axis, we will call it as moments about an axis. Okay. There are typically two approaches to studying moments. There's a scalar approach, and then there is a vector approach. Okay, so there is a couple of approaches. You can use the scalar approach, and we can use the vector approach. And in this particular concept talk, I'll be talking about the scalar approach, and then in the next one, we will be looking at the vector approach. Okay, all right, so here is the new title for us. So the scalar approach to moments. All right, and in this approach, let me start by taking a hypothetical beam. Okay, so I'm going to consider a beam. Okay, so consider a beam, a pinned beam, let's say, with a force acting on it. Okay, and I'm going to draw that beam right here, and we're going to be keeping making use of this beam for the rest of the analysis. Okay, so I'm considering a beam that is very thin. So the assumption is that the width of the beam is of no consequence to me. Okay, and this beam is pinned at this particular point, let's say. Okay, so there is something called a pin support, and you will come across this later on. Okay, when we look at rigid bodies and so on. Okay, so this is an example of a pin support. Okay. And the other thing, the assumption that we are making is that the weight of the beam is fairly negligible and its width is also fairly negligible. Okay, so let me write that down. Okay, consider a beam and forces acting on it. So we shall neglect the width of the beam as well as its weight. Okay, I'm not going to state that weight statement here because I'm not interested in it yet. All right, now on this beam, let's say that the point that is pinned, I'm going to call that as the point O. Okay, and let me say that on this particular beam there is a force acting, and I'm going to call that force as capital F1. Okay, so here is the point O, if you wish. Okay, so there is a force that is acting on this beam, and I'm going to call that as F1. So this is the force of magnitude F1, and this is acting at this particular point on the beam, which is the point A. Okay, so in this, I'm going to call the point O as the point of interest. Okay, so point O is called the point of interest, and then point A is called the point of application of the force. Okay, so point A is the point of application of the force on the body. Okay, why am I interested in point O is because I want to calculate the moment about the point O. Okay, we want to calculate to find moment about the point O. And one more thing that I'm going to write out here is this line that I'm extending the length of, I'm extending the force itself. Okay, and then I'm saying that, okay, hey, the line that I've drawn here, which I can draw as dotted lines, if you will. Okay, this is called the line of action of the force, which you already know from our previous concept talks. Okay, this is called the line of action of the force. That's also a key statement that you want to keep a note of. Okay, so line of action of the force, then I have something called as the point of interest. Okay, and then I have the point of application on the body. And let me further say that the distance from the point of interest to the point A is given as a distance d1. Okay, so I'm going to mark that distance here. Okay, so this distance I'm telling is a distance d1. Okay, so d1 is a distance from point of interest, which is point O, to point of application of the force F1. Okay, the point of application, I guess, is the point A, so let me scoot this and write that down here. So the point of application is the point A of the force F1. All right, so with this particular figure, I'm going to take this figure and copy it further down. Okay, because I want to make use of it again. And using that particular figure, we're going to define the moment of a force. Okay, but before I do that, I'm going to draw a coordinate frame. I'm going to set up a coordinate frame. Okay, so here is my coordinate frame. I'm going to call the horizontal axis as the y-axis. I'm going to call the vertical axis as the let's say the z-axis, and I'm going to call the third axis that is coming out of the plane of the paper as the x-axis. Okay, so this is the x-axis, this is the y-axis, okay, and this is the z-axis. Traditionally speaking, we would make use of x and y as the axes along the plane, so later on we will get used to that particular idea. Okay, now here is the crucial thing. By definition meaning that by experimental evidence it has been found the following is true. Okay, so by definition, the magnitude of the moment of the force F1 about the point O. Okay, so I'm going to write this down. So magnitude of the moment of force F1 about point O is given by the product of the force F1, which means that its magnitude, okay, and the perpendicular distance from point of interest to the line of action of the force. Okay, the important thing is that, okay, what are the terms of importance here? Magnitude of the moment is given by the product of the magnitude of the force itself and the perpendicular distance, okay, from the point of interest to the line of action of the force. Okay, and what do we mean by that here? Okay, so in this case, if you see, the magnitude of the force is F1 and the perpendicular distance from point of interest to the line of action is the distance d, because you see that it's making a nice right angle there. Okay, so for us this means that we're going to be writing it in the following manner. Okay, so magnitude of the moment about the point O due to the force F1 is going to be the magnitude of the force multiplied by the distance d1. Okay, this is the magnitude of the moment. How do we get the direction of the moment? Because moment is a vector, we need a direction as well. So direction of the moment is given by what is called as a right hand rule. This is the single most important thing that you will learn in statics, in a sense, how to make use of the right hand rule. And the right hand rule, I'm going to underline the steps here. Okay, so first step is align the fingers of right hand along the line of action of the force. The second thing is, as you align your fingers, your palm should be facing the point of interest. Okay, and your palm of right hand faces the point of interest. Then what do? You curl your fingers once you get to this particular step. Then the direction of the curl gives you the sense of the moment. Okay, so the direction of the curl gives the sense of the moment, and direction of the thumb gives the direction of the moment. Alright, couple of keywords right here. Okay, align the fingers of your right hand. Okay, this has to be aligned along the line of action of the force. That's the first thing. Then the palm of your right hand, once you align it, will be facing the point of interest. Okay, then what you do after that, you curl your fingers. Okay, the curl will give you the sense of the moment. When I say sense, it means it's either clockwise or counterclockwise. And the direction of the thumb will give you the direction of the moment itself. Okay, and then here is what we do. We go back to our figure. Okay, we go back to our figure, and then I say, okay, I'm going to practice this on this particular figure, and I hope you're going to be doing it along with me. Take the fingers of your right hand, okay, and align it with the direction of the force F1. Okay, your palm should be facing the point O. Then curl the fingers of your right hand. You will see that your thumb is pointing out of the page, which means that the thumb is pointing along the x-axis. And I'm going to direct that as two double arrows. Okay, so this is called the direction of the moment. Okay, and then the curl of the fingers, which I'm going to mark in this kind of a curly arrow, this is called as the sense of the moment. Okay, the direction of the moment is the same as the direction of the thumb. Okay, the sense of the moment is the same as the curl of the fingers. Okay, and what is the meaning of the sense of the moment? The idea is the following. So if I were a person, so let me take this x-axis and put it down here. Okay, so if I were a person who was standing, let's say here, and then I was watching what is going on. Okay, the sense of the moment will tell me, hey, according to me, is the moment clockwise or counterclockwise? Okay, the direction of the moment will tell me, okay, is the moment directed towards me or away from me? Okay, so I'm going to write that down here before I end this particular concept talk. Okay, so the sense of the moment says whether the intended rotation that the force is trying to cause is clockwise or counterclockwise. Okay, and the direction of the moment signifies whether the moment is directed towards us or away from us. Okay, directed towards us or away from us. And this is seen by the perspective of this particular person who is standing on the positive side of the x-axis and viewing everything. Okay, all right, and one very last thing is that we will be following a sign convention. And sign convention is because this has been historically followed, and so we're going to continue that particular tradition. Okay, the sign convention is the following. Counterclockwise moments are always treated as positive. Okay, so counterclockwise. And here is my shorthand notation for that. Or CCW moments are positive and clockwise moments, which are CW moments, these are treated as negative. And when I go back to our figure here, okay, we can now say the following. If this is my x-axis, y-axis and z-axis, this is my unit vector j. I have my unit vector which is little I, as you know, right? And then I have the unit vector k. And as you further know, any moment is a vector, and any vector is magnitude times its unit vector. So if I write this moment this way as a vector, okay, this is its magnitude, which is f1 times d1 times the unit vector in the direction that it is pointing. So this is I, this is the moment expressed as a vector. Okay, and the I direction is the direction that the double arrows are pointing towards. All right, so very brief summary of what we have done here. Okay, we looked at the basic idea of what a moment is. Okay, moment is a vector. Moment is a vector because the magnitude depends on how large or how small the force is. Magnitude also depends upon where the force is acting on the body. Then the direction of the moment depends upon the direction of the applied force. And all of these we will see in some problems that we will be solving. Moments have two ideas, a scalar approach and a vector approach. Scalar approach to moments, here is the basic idea. We have a beam, then we have a force acting on the beam. There is a point of interest, and then there is a point of application of the force. Okay, the point of application is the point A, point of interest is the point O. I extend the line of the force, that's called the line of action of the force. And if I want to find the moment of the force F1 about the point O, the magnitude of that moment is the magnitude of the force times the perpendicular distance from the point of interest to the point of application, and the direction is given by the right hand rule. Align the fingers of your right hand with the force F1. Your palm should be facing the point of interest. Curl your fingers. Direction of the thumb comes out of the page, which is the direction of the x-axis in this particular problem. Okay, and I can write it as a vector by saying, okay, magnitude times the unit vector I. And lastly, we have the sign convention for the moments. Counterclockwise moments are treated as positive, clockwise moments are taken as negative. Sign convention is because of historical reasons. Okay, all right, I hope all of you stay safe. Thank you very much.